Hi guys, so we're on our fourth day of series and sequences. Today we're going to move from arithmetic sequences and series to geometric. And I'm going to move pretty quickly because the idea is very much the same, except with geometric we multiply instead of add to get from one term to the next. So what I took 3 days for with the arithmetic sequences to make sure you understood the terminology and the symbols, I'm only going to take 1 day for today. My suggestion to you is if you have not yet caught up with days 1, 2, and 3, don't proceed with this video until you're really comfortable with those days. Also, you may be able to fast forward through a lot of this. I do a lot of review with terminology, and you'll see that, of course, math is consistent, and so you may just want to look at a practice problem, try it, fast forward. So this might seem like a long video because we're doing lots of good math with geometric sequences and series, but again, if you're really good with the arithmetic ones, this is going to be easy. These 2 pages are a review of vocab, so I'm not going to talk you through them again. Just make sure you have it. And here we are on page 121, geometric sequences. A geometric sequence is a sequence that follows a pattern by multiplying a fixed amount from one term to the next. So with arithmetic we add, with geometric we multiply. Like with arithmetic, the number multiplied each time is constant, and we call that constant the common ratio. So now you need to start studying the differences. If it's arithmetic, we have a common difference. If it's geometric, we have a common ratio. On to page 2.2. So here are some examples finding the common ratio. So you're thinking, what number do I multiply by each time to get to the next number in the sequence? And number 1, I'm multiplying by 2 each time, so my common ratio is 2. We call it R, where with arithmetic sequences we called it D for common difference. And number 2, I'm multiplying by -2 to get from one term to the next, so my common ratio is -2. And in number 3, it may not be quite so obvious, so you can either look at the pattern for numerators and denominators or go to your scratch pad and take one term and divide it by the term in front of it. So you could do 8/3 divided by 4 or 16/9 divided by 8/3, and you don't really need the scratch pad. You could use scrap paper and remember your fractions rules. But in any case, do what you need to do. Even with fractions, math is consistent. I take one term and divide by the one in front of it to figure out my common ratio. I choose to take 8/3 and divide it by 4, the number in front of it, and I see that my common ratio is 2/3. So the answer to the third example, the common ratio is 2/3. And I'm just trying to make it pretty. Okay, page 2.3. Here's a formula to find any term of a geometric sequence. Again, like the arithmetic sequences, this is one you need to know. A sub n is equal to a sub 1 times r to the n minus 1. So that's the formula. You need to know it. It's similar in its use with arithmetic sequences. A sub 1 is the first term. R is the common ratio, not ration, ratio, and n is the number of the term you're looking for. So if you want the 57th term, you plug in 57 for n. Like arithmetic means, we also have geometric means. Geometric means are the terms between any 2 non-successive terms of a geometric sequence. And from here on out, we're going to go to paper. The rest of this Inspire document are sample problems. So before we do this example for geometric means, I just flip through to show you the rest of the examples on your Inspire, and then we'll go to the Elmo and finish up. So to find geometric means, same process, math is consistent as finding arithmetic means. So I need the 3 numbers between 8, so I leave 3 blanks after 8, and 40.5. So I'm going to use my formula for finding any term in a geometric sequence. Again, it's the one I need to know. It's not given to me. And that's a sub n equals a sub 1 times r to the n minus 1. Well, here I have 5 terms, so a sub 5 is equal to the first term times the common ratio is what I need to find to the 5 minus 1. Substitute. My fifth term is 40.5. My first term is 8 times r to the fourth. Get r to the fourth alone. Go to your scratch pad. 40.5 divided by 8 is 5.0625. Don't round to those common ratios. So 5.0625 is equal to r to the fourth. We can undo that by either raising it to the 1/4 or fourth rooting, both sides. They mean the same thing, so it doesn't matter which you choose. Choose the one you understand best. And go to my calculator. And I'm going to raise it to the 1/4 just to keep reviewing the fraction exponent rules. And I get 1.5 as my common ratio. Well, now that I've determined the common ratio, I can fill in the blanks. I need to multiply every term by 1.5 to get to the next term. So I multiply 8 by 1.5, and I get 12. Then I multiply 12 by 1.5, and I get 18, and so on. You can fast forward through this, check your math as necessary. You probably don't need to see me typing everything times 1.5 over and over again into the calculator. 27 times 1.5, I still do that to check, had better give me 40.5. And sure enough, it does. Okay, so my three geometric means between 8 and 40.5 are 12, 18, and 27. Page 2.5. You're asked to find the seventh term of that geometric sequence. Well, first I can see that my common ratio is 3. I'm multiplying by 3 to get from one term to the next. So it's geometric. My first term is 2. My ratio is 3. And I'm looking for the seventh term, so n is 7. Substitute those values into your geometric formula and solve. Again, if you understand the formula and you know how to substitute in, feel free to fast forward and check your answers against mine. Once I have 2 times 3 to the 6th, I can go straight to my Inspire, type that in, and I get 1,458. Seventh term of that geometric sequence. Number 2 is very similar. I'm asking you for the 8th term of a sequence. So again, if it were me, I would try it on my own, fast forward, check your answer against mine, and then if you don't get it, go back and watch the process, see what went wrong. So the 8th term of that sequence is 411,772. Okay, problem 3 introduces you to the formula for the sum of a finite geometric series. Again, like the arithmetic series, you do not need to memorize this sum. It's given to you on your formula sheet, your Regents reference sheet. so you just need to know how to use it and what the parts mean. 3-1 just gives you the formula. 3-2 is asking you to find the sum of the first 8 terms of that sequence. So I'm going to plug in. The sum of the 8 terms is equal to the first term, -5, times 1 minus the common ratio, in this case is -3, to the 8th. I'm looking for the sum of the first 8 terms over 1 minus -3. Now you could follow PEMDAS if you want, but I sure like to go to my Inspire and use my fractions template and my parentheses and type in exactly what I see. It saves me a ton of time and lots of opportunities for mistakes. And then I'll get my answer. So type into your Inspire exactly the way it looks. And we get 8,200. Okay, on 3-3, I tell you that the third term of a geometric sequence is 3, and the 6th term is 1/9. We want to find the first term. So again, I like to draw myself a picture with blanks to try to get a picture in my head or on my paper of what's going on. And what I'm going to do here is fill in the blanks that I know, and then I'm going to call that 3 my first term just for a few minutes so that I can figure out what the common ratio is, and then I can work backwards to try to find that first term. So I'm going to call that 3 the first term just for now, figure out what the common ratio is, solve for r in my finding the term of a geometric sequence formula, and then go from there. So one more time, I'm letting 3 be my first term, which means 1/9 is my fourth term. And I solve for r. What you should be noticing is often you need to use your formulas, either that you need to know or that you're given, in kind of creative ways to find the missing pieces so that then you can use them in more straightforward ways. There are not a lot of formulas for series and sequences, so it's just a matter of finding the ones that work for you. So here my common ratio is 1/3, so I can work backwards, dividing by 1/3 each time. 3 divided by 1/3 is the same as 3 times 3, which is 9. 9 divided by 1/3 is 9 times 3, or 27. So the first term is 27. I'm also showing you how to do this using that formula again. If you are uncomfortable with fractions and dividing, you could always plug back into the formula to find the real first term, knowing now that your third term is 3 and your ratio is 1/3. Lots of great algebra skills. Again, here I see that the first term is 27. The last problem on your Inspire is a word problem. It says a ball is dropped from a height of 8 feet, so it starts at 8 feet, a sub 1 is 8. The ball bounces 80% of its previous height with each bounce. How high to the nearest tenth of a foot does the ball bounce on the 5th bounce? So the fact that the ball bounces 80% of its previous height is telling me that the common ratio is 0.8. 80% is a decimal, is 0.8. So once you understand what's happening in the problem, you can just continue filling in the members of your sequence until you get to the 5th bounce. Or you could use your how to find the 5th term of a sequence that's geometric formula and do it that way. Again, it entirely depends on your understanding of the problems and the formulas. And when I'm done, I see that on the 5th bounce, my ball bounces 3.2768, which rounds to 3.3 according to the directions. And that is it.